Good evening. Today we are going to solve two problems related with compression member. So now we have first problem, that is, so this is lecture number 9. Determine the design axial load capacity of the column ISHB 300 at 577 Newton per meter. Length of the column is 3 meter and its both ends are fixed. So this problem is given and we are interested to determine the load carrying capacity of this ISHB 350. So now we have to first go to the properties of this section. So now I will write properties of this section. So we have rolled section. So step 1 we have solution. Step 1. We can write step 1 given data. This we should be which will given data. So we have given ISHB 300 at 577 Newton per meter. L is given 3 meter and then L effective will be 0.65 into 3000. Now you can see we have both ends as fixed. And if we will go to table 11, we have condition for both ends fixed. We have in this fashion, which will be 0.65 L. And then this comes 1950 millimeters. So we have effective length 1950 millimeters. Now we will go to properties of this section, step 2. Properties of section. So we have depth, that is H, we have 300 millimeters. BF, we have 250 millimeters. TF, 10.6 millimeters. Then area, 7484 millimeters square. And then we have to go for first classification of section. So this will be step 2. Now we will go to step 3. Classification of section. Classification of section, and we have to go to table 2. Table 2, and in table 2 we have first we have the table 2 that is on page number 18, and for rolled section we have B by TF. So we have B by TF, and BF, B is BF by 2 by TF, and BF we have 250 by 2 upon TF 10.6, and we have this value, that is 125 divided by 10.6, 11.79, and this is less than 15.7, and therefore flange is semi-compact. Flange is semi-compact. Now we will go d by tw. It is symmetrical, so neutral axis lies at center. So we have value of d by tw. So we have h minus 2tf divided by tw. So we have h, that is 300 minus 2 into 10.6 divided by tw. Value of tw, we have ISHB 350. So we have to just go to ISHB 350. So ISHB 350. So we have TW 8.3. And then we will get this value, that is equal to 300 minus 2 into 10.6 divided by 8.3, 33.59, which is less than 84. And therefore, web is plastic. And therefore, section is semi-compact. Section is semi-compact. And therefore, AE equal to 7484 mm square. If you will not go for this step of classification, you will lose 2 marks for this. So you have to go for this. Then we have step 4. Then step 4, we have to go for buckling class. Buckling class. Now we have for this buckling class table 10. Now first we have H by BF. H we have 300 divided by 250. And this comes 1.2. This goes. And TF is less than 40. And therefore, if we will go to table 10, then we have buckling class B for ZZ, class B for ZZ axis, and class C for YY axis. And therefore, we have to use, so take class C. And we have for this table 9C. Then we have next step, that is step number 5, design compressive stress. Now we are going to calculate by both formula also and by table also. Because sometimes if your value goes above that value is given in IS code 10 and 250, then you have to go for basic. Now we have R minimum, which is equal to RYY, that is equal to 51.8 millimeters. Then we have FCC. Now you have to go 7.1.2. So we have pi square E upon KL upon R square. And then we have this as pi square E and KL upon R. KL we have 1950 upon 51.8 square. And if we will calculate this value, it comes 1392.9 Newton per mm square. Now knowing this value, we will calculate value of lambda, which will be FYY upon Fy upon FCC. Now we know Fy we have 250 divided by 1392.9. And if we will calculate this value, we have this as 0.42. Now just 1 minute, I will calculate value once. Otherwise, all will go wrong. X inverse into 250 to the power 3 into pi square. So pi square into 2 to the power 5 divided by 1950.51.8 square 1392.9. X inverse into 250, root of this is 0.42. And then we have buckling class C. Buckling class C. So we have table 7, imperfection factor. Table 7, alpha is equal to 0.49. And from this we will get phi is equal to 0.51 plus alpha into lambda minus 0.2 plus lambda square. And if we will put these values, so we have 0.5 in bracket 1 plus 0.49. We have lambda 0.42 minus 0.2 and lambda square, we have 0.42 square. And if we will solve this value, we will get value of phi that is equal to 0.64. Now knowing value of phi, we can find value of FCD, and that is equal to Fy upon gamma MO divided by 5 plus phi square minus lambda square to the power 0.5. And then we will get 250 divided by 1.1 upon 0.64 plus 0.64 square minus lambda, we have 0.42 square and whole to the power 0.5. And this value comes 202.4 Newton per mm square. This is by formula. Now we will have alternative method. Alternative. Use table 9C. And then we have KL upon R, that is 1950 upon 51.8. And we have this equal to 37.64. Now we have, so from table 9C, so if we will go to table 9C, then we have these values, that is for 40, sorry, first we have for 30, this value is given 211, and for 40 it is 198. Then we have FCD is equal to 198 plus 211 minus 198 divided by 10 multiplied by 40 minus 37.64. And if we will calculate this value, so this you can see we have simple one, 211 minus 198 divided by 10 multiplied by 40 minus 37.64 plus 198, 201.1. So you can see it is very close. Percentage, if you will see, that percentage is going to be very small. And then last step, step 6, design compressive strength. Design compressive strength. PD equal to AE into FCD. AE we have now, we have seen value of AE we have 7484. So we have 7484 into 202.4. So 202.4 into 7484. and we have this value, that is 1514.76 into 10 raised to 3 newtons. So we have 1514.76 kilonewton. You can take 201, then we have very small change, and therefore strength of column is 1514.76 kilonewtons. So now we will stop here only. Remaining part we will see in the next lecture. So thank you.